Okay, we'll be starting the last unit, and for a change, I don't actually have to rush it too much this time. Okay, so we'll actually take some time and do things properly and have enough time to do the work that's involved in the unit instead of having to say, hey, do this all at home. Okay, so we'll get it all done this time. So what we're going to go over today is climate. Okay, and on Friday, we'll talk a little bit about energy transfers in a global system. And then on Monday and Tuesday, we'll be working on a climate activity. Okay, we'll have the Chromebooks. It's kind of a geography / climate kind of thing. But we should be able to get it all done in class in those 2 periods. Okay, and then obviously Wednesday and Thursday we'll be continuing on with other stuff in this unit. So energy transfers and probably wind patterns, and then it'll be Christmas holidays. Okay, so it's coming right up for us there, which is nice because we got kind of a long push here since our last break. Okay. When we come back from Christmas holidays, okay, we'll have the rest of this unit, which I should be able to do in about 5 to 6 classes, and that should leave us a little bit of time for final exam review, probably like 2 full classes, okay, for final exam review. I'm not going to actively assign you any homework over Christmas, okay? So like I'm not going to make something due on the Monday or the Tuesday after, but it would be a good idea to start getting things organized over Christmas in preparation for your final exam. Okay, because that's going to come up really fast. I mean, we're back on the 9th of January. Okay, exams start like, what is it, 9 or 10 days later. Okay, and that includes the weekends. So it's going to be really quick where it's going to turn around and you're going to be writing finals for the first time in high school. So make sure you start getting everything a bit organized over Christmas. Take all your books home. Okay. Obviously in science, with most of it being digital, you don't have to take too much paper home, but some of it, start looking things over, looking at things and saying, what do I remember how to do? What do I probably need to ask Mr. Codere about? Because the more you prepare before those last 2 days we have for in-class review, the more you'll get out of those last 2 days of in-class review. If you've done nothing, you'll show up for those 2 days and hope other people ask the right questions. Okay. And I'll tell you, that doesn't usually happen. Okay. If you want to have your questions answered, you better have them for those 2 days. Okay, so be ready for those 2 days. Come in with questions. I imagine there'll be a lot of review of chemistry, okay, over those 2 days because it was the longest to go, okay, and it has lots of skill stuff in it. So look over your stuff over the Christmas holidays. I'm not saying like spend like 20 hours of your Christmas holiday. No, don't do that. Just take your stuff home, get it organized, and look over a couple things. Make a few notes on what do I need to ask about or what should I start looking over when school starts again. Okay, because this unit, there will be basically the climatogram activity we're doing next week, and that's about all you'll have in terms of assignable homework for the rest of the semester, from me anyway. Okay, the rest of that time should be spent studying for your final and for your last unit exam as well. Okay, so we'll try and make time for that. Okay, questions on that and where we're headed? Now you kind of know what we're doing right up till the end. All right, so for climate, okay, what is climate? Okay, world around you, a little bit. Well, there's more to it than just temperature. Temperature is part of it, for sure. Okay, and it can be influenced by things in the world around us, right? Climate in and of itself is the weather that you can expect for a location. It's the typical conditions that you can expect at a location. Okay, weather is what it is right now today. Okay, we would not describe our climate, hopefully, the way it is today, right? Because our climate is not that it's always minus 20, whatever it is out there today, okay, with winds and snow, a little bit of snow on the ground. Okay, our climate is more that we're fairly far north, which means daylight changes throughout the year. Temperature is going to fluctuate throughout the year. We have periods of rainfall that are heavier than others. We get precipitation in all forms: rain, snow, sleet, hail, whatever. Okay, that's a description of our climate, right? Not so much the weather, but what does weather do? How does weather change over the course of a year in this area? Okay, a lot of people say it's the average weather. I'm like, Well, that doesn't give a very descriptive or a very accurate description of what the weather in Okotoks is like either, because then I would say the average, so the temperature in Okotoks on average is about 4 degrees Celsius. And the wind is typically out of the southwest at about 20 kilometers per hour, and we get like 0.04 millimeters of rain per day. Okay, is that an accurate description of what it does in Okotoks? No, but those are the averages. Like, that's silly. No one describes the average unless you're in a place where the weather almost never changes. Okay, like in Hawaii. If you live, in certain places in Hawaii, being a weatherman in Maui is like the greatest job ever. You can put the same thing up for the weather for the whole week and take a break. Okay, and you'll be right. It's going to be a little bit windy, a little bit rainy, a little bit sunny every day, and it's going to be about 29 degrees. Okay, you could just put that up and leave. Okay, and not do your job for the rest of the week. Right. Whereas here, obviously, okay, we have our expression in Alberta: if you don't like the weather, wait 5 minutes. Okay. Because the weather always changes, especially in the summertime, changes very rapidly around here. Okay. All right, so we got to go over what are the components of climate. Okay, there are 4 components of climate, and then we got to look at the factors that affect climate. What is it that makes the climate here or anywhere the way it is? And there are a lot of things that do affect that. Okay, we need to look at the effect of climate on plants, animals, and humans. That's kind of common sense stuff. Okay, describe energy inputs and outputs, of various environments, and be able to read and create climatograms. A climatogram basically shows you, it's a graph that shows you temperature and rainfall over the course of the year. Okay, so it's got 12 points, 12 temperature points, 1 for each month, 12 precipitation points, 1 for each month. Okay, and we'll look at what those look at here in a minute. All right, so a strict definition of climate would be the prevailing weather conditions at a location. Okay, so what can you expect in terms of weather for a certain place on Earth? Okay, the major components of climate. Okay, and we got to make sure that we don't confuse factors affecting climate with components of it. Okay, the major components of climate are temperature, precipitation, light, and winds. I mean, when you open up the weather app on your phone in the morning, those are pretty much the 4 things you want to know. Maybe not light so much, but it's one of the ones I always look at. Okay, but certainly you want to know, is it going to be windy? Because that can affect the wind chill. Okay, is it going to rain or snow or hail or whatever? Okay, is it going to be sunny? Right, those kind of things. Those are the things that we want to know. How warm is it going to be? Okay, with light. Okay, because light's kind of the odd one. Do I mean, is it going to be cloudy or sunny? Sometimes. Okay, that can certainly be a factor affecting climate. Here, it's typically clear a lot more than it is cloudy. We get over 300 days of sunshine in a year, right? Or if you go to Victoria, it's almost the opposite. Okay, they get around like 45 days of sunshine a year, okay, and the rest of the time it's cloudy. So certainly that can affect the quality of light and the intensity of the light received in that area. It also means that probably one area gets way more precipitation than another, which is why there's a temperate rainforest in the coastal BC areas, whereas here it's prairie and quite dry. All right, but the other thing about light has to do with where on Earth you are. The further from the equator you are, the more your light fluctuates throughout the year. The closer to the equator you are, the less it fluctuates. Okay, and that's because the Earth is what? It's what? Okay, the Earth is, very slightly elliptical, but that's actually not what causes it. But it is actually just slightly elliptical. Yeah, it's tilted. Okay, the Earth does not sit straight up and down like this. Actually, it does 2 days a year. Okay, 2 days a year the Earth looks like this. Okay, the rest of the time the Earth is tilted, 23.5 degrees actually, which is a fairly significant tilt. All right, what that means is as we go around the sun, the amount of sunlight and the quality of sunlight that we receive is going to change. So here's the sun, okay, and here's the Earth in its orbit. Okay, so. And the Earth's orbit is elliptical, so that's actually not all that inaccurate. It's just because I can't draw. All right, so with the Earth's 23.5 degree tilt, okay, over here, the Earth is tilted like this, okay? This is the North Pole and this is the South Pole, okay? When we're at this position, okay, it's still tilted like that, north and south, okay? Over here, north and south, and down here, north and south. Okay, what day of the year is it when the Earth looks like this? December 21st. What do we call December 21st? Winter solstice, shortest day of the year. Because as the Earth rotates on its axis, the sun shines on it this way. So us and anyone else that are over here by the North Pole, okay, basically don't get into the sun very much. And the sun is at a very low angle, right? Over the next couple of days, watch the sunrise. Okay, and just kind of don't stare at it though, because that's bad for your eyes. Okay, just kind of watch the sunrise. Okay, so as the sun rises, you'll notice it rises like over there, okay, to the southeast, and it follows this very pathetic little arc, okay, that doesn't take it very high in the sky right now. It just follows this small arc and sets kind of over there in the southwest, and never gets very high. Never stays doesn't stay in the sky very long. Okay, right now I looked at the weather for December 21st. We are going to get 7 hours of sunshine on December 21st. Okay, it's the shortest day of the year. The sun will be in the sky for 7 hours. Okay, that's because the Earth spins this way, around and around, right, like this. But the sun shines on us like this. So anything on this side over here, it's daytime. Anything over here, it's nighttime. Okay, and we stay in that nighttime side a lot more on December 21st. Okay. Yes, we do. I'll check. Okay, so for Calgary, okay, so sunrise on December 21st. Actually, that's only going to be, well, it says 8 hours on here. Okay, anyway, this first website that I found says sunrise will, oh, this is today. Okay, well, it won't be much different by December 21st, but today it's 8:33 a.m. and it's setting at 4:30. Okay, so we lose on average 6 minutes per day. Okay, so yeah, but anyway, so I would imagine that we're looking at probably somewhere around a like 8:50 sunrise. Okay, and probably, or sorry, maybe like an 8:43, 8:44 sunrise, and about a 4:15 sunset. Okay, you lose 3 minutes on either end, right? Every day you lose 3 minutes on either end, 6 minutes in total, okay, as the day changes. So that's what we got coming up. Now, what day of the year is it? Okay, right here. Yeah, this is March. Yeah. The Earth goes this way. We'll say the Earth goes this way. Okay, so this is March 21st, the first day of spring. We call that the spring what? Equinox. Okay, because the Earth's tilt is now perpendicular to the sun, everybody gets 12 hours of sunshine and 12 hours of darkness on that particular day. The same is true here on the fall equinox, September 21st. Okay, this is my favorite day of the year. June 21st, okay? Because I can put my kids to bed and fish for 5 or 6 hours after that, and it still won't be dark. Awesome. best day of the year. Okay, so yeah, so the reason for that is because now the North Pole, where we live, well, not right at the North Pole, but obviously the Northern Hemisphere faces towards the sun, okay, because we're not elves and I'm not Santa Claus, okay? We face towards the sun, and when the Earth spins around on this axis, we stay in the sun a lot more, and on these days, the sun rises almost in the northeast, okay? And so it gets directly overhead and sets, okay, over in the southwest, and we get this very intense, much hotter sunshine. Okay, so that's the effect of where you are on Earth on light. Okay, there's a much better diagram of that right here. Okay, so now we're going to go into the factors that affect climate. So the four components are light, temperature, precipitation, and wind. Okay, these are the things that affect those four things. Latitude is the single greatest factor on your climate. Okay, it influences your climate more than anything else. So inputs of solar radiation decline rapidly away from the equator. So we're looking at the Earth here on either March or September 21st on the equinox, when we're essentially straight up and down. Okay, at the equator, sun is directly overhead. Okay, you are getting very intense sunshine at the equator, basically all days of the year. Right? So the sunshine falls on an area about as long as that line. Everybody okay with that? As I go further north, because the Earth is round, and of course it worsens as the Earth tilts, okay, that sunshine now falls on an area that is greater. Okay, you can see that my line now doesn't cover the entire space where that same amount of sunshine is falling. So that means the sunshine is now less intense. So it is cooler here. Okay, same is true the further north we go. Okay, because the Earth is round, that sunshine is falling on an even greater area now, which means even less intense. In the summertime, when we're tilted towards the sun, then we're more like this area, okay, down below. We're more like this, and the sun is more directly overhead, so it's hotter. Okay, at the equator, well, as long as you stay between the Tropic of Cancer and the Tropic of Capricorn, you really don't notice much difference. Okay, that's it's 23.5 degrees north of the equator and 23.5 degrees south of the equator. It just happens to be the same as the tilt of the Earth. Okay, so between those latitudes, you don't really notice very much difference. Okay, I think I told you guys the story of the hotel clerk in Hawaii who was complaining about how short the days were getting. Okay? Like, I went to Hawaii for my sister's wedding, and the hotel clerk in August was complaining about how much shorter the days were. And I was like, really? Like, the days are shorter here. I get that because, you know, we're closer to the equator than we are when I'm at home. Okay. She said, but yeah, it's, you know, the days have gotten about, like 2 or 3 minutes shorter. And I'm like, what's your shortest day? Like, really, what's your shortest day? She said, oh, it's about 11 hours. And I think she said it was 11 hours and like 5 minutes or something like that. I'm like, you have no clue what a short day is like. I mean, that's a short day in the summer for me, because in the summer I'm used to 18 hours of sunshine. But in the wintertime, 11 hours and 5 minutes would be pretty good, because I'm getting a 6.5 hour sunshine day, okay, on that particular day. All right, so everybody follow the effect of latitude, okay? As you go away from the equator, inputs of solar radiation decline, okay? If inputs of solar radiation are declining, the amount of energy available to affect things like temperature, to affect the water cycle, okay, all of that kind of stuff, to make wind, are all declining. Okay, it's the energy from the sun that drives everything, and if your solar inputs are declining, you're getting less and less energy. And of course, as we've already pointed out, the tilt of the Earth also plays a part in that, okay, as we go through the seasons. Okay. Next thing that can affect your climate, okay? So, and these are kind of in order of importance. So if I gave you a question on a test that said, here's a city in Canada, list some factors affecting its climate, should latitude be one of the things you list? Latitude should be something you list no matter what city in the world I gave you, okay? Because if I gave you something near the equator, latitude's still affecting its climate. It's close to the equator. It gets even amounts of high intensity sunlight all year long. Okay, next factor. Altitude. Altitude plays a big part in your climate, because as you go up in altitude, the atmosphere gets thinner and its ability to retain heat decreases. Okay, that's why the tops of mountains can keep their snow well into June some years. Okay, maybe even July. Some places, obviously, like the Columbia ice field, then the ice is there year round. Okay, that's because the temperature in those places is lower all the time. Every 1,000 meters you climb, the temperature will change by about 6.5 degrees. Okay, now that's not a hard and fast rule. Okay, there's been times where I've climbed a mountain and it's, the temperature has changed a little bit, but not necessarily by 6.5 degrees. Okay, and there are other times where it's been worse than that, but on average, it's about 6.5 degrees. Okay, this particular picture here, okay, well, you guys were very little when I took this picture, but okay, I should really take the date off of that because it's kind of embarrassing. But my dad and I were on a backpacking trip. This is Mount Robson, okay, the highest peak in the Canadian Rockies, okay, and we were hiking out from Berg Lake, which is like down there somewhere, okay. When we left Berg Lake Campground, it was raining a little bit, and it was about 14 degrees, okay. When we got to this part here, which is Snowbird Canyon, I think it's called. Okay, we were about 1,200 meters higher, and it was only about 8 degrees. Okay, at this point, so it had dropped, our 6.5 degrees or so. Okay, on the top of the mountain that day, okay, there were two climbing groups. Okay, and one of them had a fall. Because at the top of the mountain, it was well below freezing. The winds were blowing really, really hard, and it was blizzard conditions. Okay, still raining here. It was starting to snow a little bit. Okay, as we went up a little bit higher, it started to snow. That's where we turned around, because smart hikers and climbers turn around when weather gets bad. They don't continue to push on and get blown off of mountains. Okay, but there were some people at the top that were up there, and they were in like complete whiteout conditions and could not see where they were walking. Okay, one of them fell. Okay, so be smart when you're climbing. Okay, be smart when you're climbing. You don't want to take a bad fall. Okay, because you can't see where you're going. But yeah, the temperature decreased pretty rapidly as you went up, and obviously Mount Robson is quite tall. Okay, we were nowhere near the top of it. Okay, here, so the temperature had the opportunity to decrease probably by another 15 degrees between where we were and the altitude at the top. Okay, so well below freezing at the top. Okay, so if I have two places that are similar in latitude, okay, but considerably different in altitude, they could have very different weather conditions. Everyone all right with that idea? Okay. All right, like if you look at, let's say, Denver, Colorado. Okay, Denver, Colorado is a very high altitude city. Right? There are other cities that are a similar latitude to it, but are much warmer. Okay, Denver is quite a bit colder than most cities simply because of its altitude. Okay, distribution of land and sea. That is the proximity to the ocean. Can the ocean affect your temperature? Yes. Absolutely. Okay, Victoria and Calgary have similar latitudes. Okay, or Victoria and Lethbridge have similar latitudes, but it would arguably be a lot warmer on average in Victoria than it is in Lethbridge. Okay, because Victoria is where? Yeah, it's right on the coast, right? So if you live on the coast, okay, over here in the Pacific, you've got all of this water, okay, that's over here. And water can retain heat. Okay, it has what we call a very high heat capacity, which is something we'll talk about after Christmas probably. Okay, that means that it takes a lot of energy to change its temperature, or it has to lose a lot of energy to cool its temperature, right? About 4.2 joules for every gram of water to change 1 degree. All right. Now, in the Pacific, around these kind of areas here, does the ocean freeze? Nope. Okay. So if the ocean's not freezing, then the temperature of the ocean is obviously above zero, and it's probably considerably above zero. Although if you've ever swam in the ocean out here, it's frigidly cold. Okay, but it's not freezing. What that means then is that the air above is also going to stay relatively warm because of the second law of thermodynamics. Okay, energy is going to flow from the hotter water to the colder air and raise the colder air's temperature, which means the temperature of the air can rarely get below freezing because of the proximity to all that warm water. Okay, so proximity to a large body of water like an ocean or maybe a very large sea, okay, can affect your temperature, okay, and it can regulate it and keep it lower. Do we have any of those in Alberta? No. Okay. I had somebody say like, well, what about Cold Lake? I'm like, well, that's a big lake. It is, but it freezes over in the wintertime. Okay. And it's, yeah, that's no good then. It's the temperature of the snow on top is the temperature of the air outside. It can be minus 30. Okay. It's not going to work if the body of water can freeze. Okay. So we've got to talk basically about an ocean that isn't going to freeze. If you go up to Alaska, okay, up in these kind of areas here, the ocean does freeze up there in the wintertime. Okay. Like you can, there's actually one place where you can almost walk across, okay, from like one of the islands, the Aleutian Islands in Alaska, where you can actually walk from American soil to Russian soil, walking across the ice. Okay, it's pretty crazy. Intercepted, I maybe. It's not like there's anything valuable in those parts of, like no military installations or anything to really worry about. Okay, over here, okay, now you can see that the ocean, the other thing here is the nature of the ocean currents, okay? The nature of the ocean currents over here, okay, on the west coast is actually bringing kind of colder water in, okay? So we've got these blue lines here showing some ocean currents, okay? Over on the east coast, okay, there are different types of currents. There's the Gulf Stream, which is bringing water from the Gulf of Mexico, and that water is fairly warm, okay? We got the North Atlantic Current, which is also bringing fairly warm water, but we have the Labrador Current that runs right down, okay, across like Newfoundland and Labrador and those kind of places along the Grand Banks that is frigidly cold. Okay, and that can make the water in those areas quite cold, and then it can affect the weather. So you've got lots of moisture, but it's also very cold, so they get lots and lots of what? Snow. Okay, if you've ever been to Newfoundland in the wintertime, okay, they get way more snow than we do. Like they can get feet of snow all at one time. Okay. Other things that large bodies of water can affect, okay, if we're looking at the Great Lakes, okay, the Hudson Bay could also be considered a large body of water, okay, but the Great Lakes can also affect weather, not so much temperature, but they can affect precipitation. If you live in like Buffalo, New York, and places like that, they once in a while will get what's called lake effect snow, which means warm air, okay, moves across the lakes, and the lakes have gotten colder, okay, so as the warm air moves across the lakes are so cold that they bring the temperature of that air down, and then they can cause the moisture in that air to condense and then fall as very heavy snow on the windward sides, okay, of those lakes. So places like like in Buffalo, they'll have a lake effect snow and they'll get 3 feet of snow in a few hours, okay, just because all that snow, all that moisture gets brought down quickly. Okay. All right, so warm water or cold water currents can influence temperature patterns of nearby land, okay, and that can affect your temperature, sorry, your precipitation as well. Okay, El Nino and La Nina are also ocean currents, but they're not present all the time. Okay, last year was an El Nino year. That's why we had such a mild winter with very little snow. Okay, El Nino is an ocean current that wells up. It's an upwelling of warm water off the coast of Chile. Okay, down in South America. But it's such a huge upwelling that it can actually change the temperature of the entire Pacific Ocean by several degrees. Okay, when you think about that volume of water, that's a lot of energy. Okay, and that, even though it doesn't seem like very much, like only a couple of degrees, the amount of energy required to do that can cause a global temperature increase for that year. Okay, and then the following year, we get a movement in of very cold water from the Antarctic, which is called La Nina. Okay, and we're supposedly having a mild La Nina, okay, this year. Okay? It wasn't like the one they were expecting. We were supposed to get like the most brutal one ever, but it didn't happen. Okay, well, they can say that, but I don't know. The last couple of weeks have been pretty brutal. But La Nina then obviously causes the water temperature to rapidly decrease several degrees, and that can affect global temperatures. Okay, so those are big ocean currents that are always present there. Okay, distribution of mountain barriers. Okay, if I was listing Calgary, Okotoks, Lethbridge, okay, any of those kind of places around here, would this be a factor you should list? Absolutely. Right. If you go to other places in North America, like let's say you go and talk to people who have lived on the East Coast their whole life, okay, or you go down to like New York or Vermont or places like that, and you use the word Chinook, they don't know what you're talking about. Okay, say Chinook, they're like, is that a native word? And yes, okay, it is, and it's a wind, right? And it causes like really rapid warming trends, and it gets really nice, and even in the dead of winter. And people like Leonardo DiCaprio think that it's climate change because they're stupid. Okay? We know better. I hope one day he listens to one of these. It's like my hope that he finds out he's stupid. Anyway, so we got cold air, okay, or we got warm, moist air coming in off of the Pacific Ocean. So this would be over here, like by Vancouver, Victoria, that kind of place. Okay, that warm air, because of the nature of wind, where at our latitude, gets pushed west or eastward, okay, over top of the mountains. Well, as it goes up over the mountains, we know temperature decreases by 6.5 degrees every 1,000 meters. So the air cools and loses the moisture that's in it. And so it falls as precipitation on this side of the mountains, which is why we see forest, temperate rainforest on the what we call the windward side of the mountains, okay, on the BC side. As that air is going over the top, now that it's lost all of its moisture and it's really cool, it starts coming down this side of the mountains over here as cool, dry air. But it warms as it descends. Okay, there's some like friction between the surface of the earth and the air that helps to warm it. Okay, sun can shine on the mountains, things like that. Okay, that'll warm it up as it descends, and as it comes down here, it comes off the mountains as warm, dry air, which is why typically you get either grasslands or prairie or desert, okay, on what we call the leeward side of the mountains. We're on the leeward side of the Rockies, and that's why we don't have like really complex forests where we are. The air that comes off the mountains is dry and can actually pull moisture out of the ground as it blows across. That's what a Chinook does. That is how a Chinook happens, okay, and it is because of this, okay. We often call this area here a rain shadow. Because if you look at it on a precipitation map, you can actually see it looks like the mountains are casting a shadow of desert or grassland behind them. Okay, which is where the idea of rain shadow comes from. Austin, you had a question? Right. Yeah, a Chinook comes from air that is moving down the mountains and warming up. Theirs is moving up the mountains and cooling off. So they would get sea breezes, which is warm, moist air coming off the ocean. No? Okay. All right, so make sure you know the term rain shadow, and obviously, okay, this is a big deal. Okay, presence of mountain barriers is a big deal in terms of climate. The higher the mountains are, the more exaggerated this effect is. If you look at the Himalayas, right behind the Himalayas is the Gobi Desert. Okay, and the Gobi Desert is really nothing but rocks. Okay, it is extremely dry, but it's also a cold desert. Okay, it's a high altitude, cold desert. Okay, not much like ours, but more like just no really other way to describe it other than it's kind of just rocky. It's like what Arizona looks like, except cold, okay, instead of hot. The prairie is one step up in terms of moisture from the desert, okay, which is why prairie and desert often merge together. Okay, pattern of prevailing winds. Your latitude and sometimes just position due to other factors can affect where your wind comes from. And where your wind comes from can affect your weather in terms of temperature and precipitation. Our wind here typically comes from which direction? Yeah, west and southwest. If our wind is almost always coming from that direction, it's almost always bringing the same kind of weather. The only time we get really severe weather is when the wind changes and brings air from somewhere else. Okay, what direction does wind come from that almost always brings something bad? Yep, specifically the northeast. Okay, if we get a northeast wind, you can almost always bet that something is going to change pretty rapidly and in a bad way usually. Right? So what we typically have is wind coming in from this direction. Okay, and that's going to be usually like warmer because it's coming from the south. Okay, it's usually going to be dry because there's not a lot of moisture down here. Okay, where that's coming from. So that gives us our kind of stable weather conditions. But what can happen sometimes is if we get an area of high pressure and an area of low pressure, and that's kind of our next one here, centers of high and low pressure. If they start acting against each other, that's when we can get kind of channeled wind that is bringing different types of air masses together. When we get those really bad blizzards followed by really cold weather, this is what's usually happening. Right up in here is usually an area of high atmospheric pressure. Okay, it's called the Siberian High. Over here is typically an area of low pressure, right? Now, wind around high, or air rotates around areas of high and low pressure. Okay, around a high, it usually rotates this way. Okay, and around a low, it usually rotates the other way. So what happens is, out here where the low pressure area is, the rotation will draw moist air off the ocean and get it rolling down this direction. Okay, off the high pressure area, it can grab areas of really cold, dry air and send them rolling in the same direction. If those two air masses encounter each other, they travel right down there. In the summertime, yes, it can actually lead to, okay, those kind of supercell thunderstorm kind of developments because you're getting a lot of moisture with a lot of different air. Okay, in the wintertime, okay, what runs right along this line I just drew? That's Highway 2, isn't it? Isn't that Highway 2? Okay, can Highway 2 be awful when we get one of those blizzards? Because the blizzard just channels right along that highway. Okay, and it'll take all of that stuff, okay, together. You guys really got to learn your geography. Okay, Highway 2 is important geography for Alberta. Okay, so we get these cold, dry air masses meeting up with warm, moist air masses, and that's always going to create trouble. And we usually get that, or we get an indication that that's going to happen, because this high pressure area starts to rotate more quickly and bring winds coming from the northeast. Okay, if our winds are coming from where they typically come from, weather is going to be more stable. All right. I feel like a weatherman when I draw all that. Yeah. I don't know. I mean, we don't get a lot of those here. I remember that. Yeah. It's not a temperature thing. The buses will not run at a certain temperature. Like they won't run because they don't want kids. They don't want kids to sit out at the bus stops at a certain temperature. I think it's like minus 35 or something like that. Okay, it's pretty cold, right? So the school would still run because people have to have a place to go, right? The only time that school has been like actively canceled, okay, but the building is obviously still open, is if it's cold and the roads are so bad that really it's not safe for anyone to come in, right? Then we get an email, even as teachers, that says, if it's safe for you to come into work, please come into work. Right? I remember getting one of those that day and I was like, yeah, I'll get there in about 4 hours when I dig out of my house. Okay, because I had a drift. When I opened up my garage door, I could only see like this much light. Okay, because the wind had blown the snow up against the door. Okay, and I had a drift that was taller than me. Okay, but yeah, that was in 2013. We got that really big snowstorm in December in 2013, right? Yeah. No, what I did is took my truck and drove through it because I wasn't gonna. Yeah, it's like I'll move a bunch of it with my truck and then I'll shovel. Yeah. Okay, climatograms. Okay, let's refocus here, guys. Okay, climatograms. Okay, a climatogram shows us weather patterns. Okay, for, let's say, for the entire year for a particular location. And it's going to show us temperature. That's what the line represents. Okay, so the line on the graph represents temperature. So there's actually two scales on the y-axis of a climatogram. Okay, so the line graph represents the temperature, and the bar graph represents precipitation. So your scale on the left is going to be your precipitation. Your scale on the right is going to be your temperature. Right? That's not a hard and fast rule. It doesn't, as long as you label it, people will know which one is which. Okay, so we got a tropical rainforest here in Manokwari, New Guinea. Is that close to the equator? It is. What do you notice about the temperature pattern? It's pretty steady. That is indicative of anything close to the equator. Okay? Any place close to the equator is going to have very little fluctuation in temperature throughout the year, because what else doesn't fluctuate? Sunlight, right? Their input of energy doesn't fluctuate throughout the year. So they have very regular, very predictable temperatures. Does that mean their rainfall is predictable? Well, I mean, it's predictable, but it's certainly not even, okay? At least not for all places, okay? Some places in near the equator will have very even precipitation if they're like a desert, okay? Then it'd be basically nothing all year long, okay? For a tropical rainforest, they have a rainy season and a dry season, okay? Because their driest month, they still get between 10 and 12 centimeters of rain. When we had the bad floods, we got 16 centimeters of rain. Okay, so when you live in the tropical rainforest, you have to deal with the fact that it's going to be flooding a lot. Okay, and in fact, lots of tropical rainforests are continually flooded. Okay, they just get tons and tons of water. Okay, their wettest month, they get 33 centimeters of rain. Okay, so that much in a month. Okay, that's like over a centimeter of rain per day. Okay, that's crazy. Okay, we measure our rain here in what? Millimeters, yeah, because we just don't get that much of it. Okay, they measure theirs in centimeters. They measure their annual rainfall in meters. Okay, we can measure our annual rainfall still in millimeters, and it's not all that big a number. Okay, mid-latitude deciduous forest. What do you notice happened to the temperature bar? Or sorry, the temperature line. Okay, what shape did it assume? It's actually called a bell curve. Okay, because it's like the surface of a bell. Okay, so as you move away from the equator, your amount of sunlight begins to fluctuate, and your temperature will reflect that fluctuation. Your summer months will be your warmer months, where you're getting more intense and more hours of sunshine, and your winter months will be lower. Okay. So this is mid-latitude, so Nashville, Tennessee. So let's say, kind of the middle of the United States kind of an area, so much further south than us. And what do you notice about the rainfall? It's a lot less than the rainforest, and it's also more steady. Yeah. Okay. Typically, when you have a deciduous forest, you have more steady rainfall. If you go and look at central Canada, so like Manitoba, well, western or eastern Manitoba, Ontario, Quebec, New Brunswick, those kind of places that have the deciduous forest with lots of maple trees and things like that, they typically have a much flatter precipitation pattern. Okay. Their precipitation is much more even. Now, does that mean that this is all rain? No. Okay, it's still going to be snow in the winter, but we measure snowfall in the same way. Okay, here's the thing though. Snowfall doesn't represent as much moisture as rainfall. So if we get 10 centimeters of snow, that's the equivalent of 1 centimeter of rain. Okay, why is that? Partially. Also because, oh yeah, I think that's the same argument, but yeah, there's air between them, right? Snowflakes, when they fall and hit each other, they interlock and they make air spaces in between, which is why snow is such a good insulator, okay? But it's full of air, right? You have to, when it melts, it takes up way less space. Okay, that's why it looks like it shrinks, okay, as it ages or melts a little bit, okay, because we're losing the air spaces in between, okay? And then this one here, we've got the taiga in Anchorage, Alaska. So much further north, but remember, Anchorage is also close to the ocean. Okay. So if we look at their temperature pattern, it still has the same shape, but what's different about their temperature line compared to Nashville's? It's lower. Okay. So as soon as you see the bell curve, you know you're not near the equator anymore. The position of the bell curve tells you just how far from the equator you are getting. Okay. Our temperature pattern has the bell curve as well. Okay. And it's around kind of the same place as Anchorage is. It might be a little steeper because we get a little bit warmer in the summer, okay, but about as cold in the winter. Where on earth would I get that? Right. You go south of the equator, the bell curve reverses itself. Okay. In Australia, okay, the climatograms, okay, they have, okay, their bell curve looks like this. Okay, because summer is Well, no, it's not. Summer's in the summer in the southern hemisphere. Okay, but it's in December. Okay, not in June. Right. So their bell curve is the opposite. So if I was like, this is like maybe like Antarctica. Okay, it would be, but it'd be really low. Yes, I know. I was just giving you a hard time. Okay, what do you also notice about Anchorage being quite cold? Yeah, not as much precipitation. Okay, and this would be true for basically all taiga type biomes. So that would be if you went into Kananaskis, Banff, okay, those kind of places up by Fort McMurray is also taiga. Okay, they're typically going to have not a lot of rainfall. It can actually be, it's a very dry forest, which is obviously why wildfires are such a problem. Okay, but you can see also that most of the rainfall happens in late summer and early fall. Okay, which is not typical. Okay, well, it's typical for this type of a biome, but it's not typical for most biomes. When is our wettest month? Okay, which month in particular? June. Yeah, June's our wettest month. June and July are our wettest months. Okay. All right. So, what am I going to ask you to do with a climatogram? Here's what I'm going to ask you to do with a climatogram. On a test, I would give you a climatogram and ask you, where is this biome located? Okay, so we haven't talked about biomes yet, but I would ask you, okay, this climatogram would be for what biome as opposed to what city? Okay, when we talk about biomes, you'll realize why I picked that instead of cities, okay, because it's a much broader area, okay, and you'd be able to match it up. So you'd say, okay, well, if I gave you one like this, you would say, well, that's for the taiga because the temperature line is low, it's a bell curve, so it's far from the equator, and there's not a lot of precipitation. If I showed you one like this, you would say, it's in the tropical rainforest, the temperature line says it's near the equator and the rainfall is really high. Okay, so you'd be explaining that. So you got to be able to read a climatogram and then match it up with an ecological area called the biome that we haven't gone over yet. No, it'll depend on where you are. Like this one would be one that would be better measured in millimeters, right? Because it's very small. But for the sake of consistency, I wanted them all in the same units. Is that something you should look at when you look at the climatogram? It is. It's really important that you look at the scale. How important is scale on a graph? Very important. Okay, because I've had people who I've put on a climatogram on a test and they've completely misinterpreted it because of the scale. I put on a climatogram that looked like it was really, really wet, but the scale was so incredibly small that the bars were really tall, even though that place didn't get a lot. I haven't used that one since because it seemed kind of unfair afterwards, but it seemed like a really wet place, even though the tallest bar was like 5 millimeters. Okay, it was just the scale made it seem really wet. No. Okay. We'll be doing an activity where I will give them to you and you'll have to analyze them. Okay. I mean, they're not hard to make, but just time consuming. Okay. Questions on any of those? All right. I want you guys to answer those questions right now. I'll give you a few minutes and then we'll go over. So for a central Alberta city, that would be, okay, let's say around Red Deer. All right. Components of climates. What would the temperature be like if I was describing that? Okay, it'll be a bell curve. It will be generally cool. Okay, it'll be generally cool because of its latitude. Okay, yes, it's going to get warm in the summertime, but it's going to get cold in the winter. Okay, so we're going to be looking at a generally cool climate with a fluctuating temperature. What about light? Fluctuating, yeah, okay, right. It's going to fluctuate to a maximum in June and a minimum in December. Okay, and the hours of light would range anywhere from like 18 hours down to 6 hours. What about wind? Is it as windy there as it is here? No. Okay. Red Deer and Central Alberta are quite a bit calmer, and they're actually in the transition zone between westerly winds and easterly winds. So their wind can actually come from a number of different directions, depends on the day, okay, but it isn't nearly as consistent or strong as it is here. Right? Precipitation, sorry, was the other one. Okay, what's the precipitation like? Do they get more rain or less rain than us? More. Yeah, they get more rain than us. Typically, it's more of a parkland, okay, kind of an area. So there'll be more trees, longer grasses. Okay, we typically have kind of short grass prairie here. When they have prairie up there, it's typically longer, right? So definitely more precipitation there. And again, the precipitation would be heavier in the summer than it would be in the winter, and would come in all forms. Number 2, what factors most affect the climate in our area? Number 1, no matter what place I had said, would be latitude. Okay, what else? Altitude, yeah. Okay, guys, the altitude of Okotoks is just under 1,100 meters. Okay, above sea level. So this is a fairly high altitude place. Okay, what else? Presence of mountain barriers. Yeah, okay, that greatly affects our climate in terms of how much rainfall we get, and it also affects the type of winds, Chinooks, that we get. Yeah, we're landlocked, so we could also say we're really far from any significant body of water, which means our temperature is free to fluctuate, okay, between winter and summer. Yeah, I would say also that would be in there. Okay, it's one of the kind of lower importance, but it still does affect us. We typically are affected by areas of high pressure more often than we are areas of low pressure. Okay? I would say those are probably our best ones. Again, it's saying, proximity to the ocean is, we would say we're not close to the ocean. So I don't know if I would actually list proximity to the ocean as a factor affecting Okotoks, other than to say it doesn't affect us, okay, because we're very far away. Okay, climate of Saudi Arabia in terms of the components of climate and the factors that affect it. All right, let's start with components. Light. Pretty steady. Yeah, Saudi Arabia is pretty close to the equator. What about temperature? Hot and dry and steady. Okay, I mean, Saudi Arabia is just hot all the time. Okay, we already said precipitation going to be very dry. I mean, obviously in the Middle East, there's not a lot of rain. It's pretty much a desert. Okay, what about wind? It's tough, right? That's not one we would probably guess, but they do get some wind there, and it's mostly off the Gulf, okay, off the Persian Gulf. The winds can form off of because of the differences in temperature. Okay. Factors that affect it: close to the equator, low altitude. Okay, so I mean it's pretty much, well, many parts of Saudi Arabia would be around sea level. Doesn't mean that there aren't mountains that would be higher, but close to the ocean, okay, close to the Gulf the Persian Gulf, so certainly that would affect some parts of its climate. But actually the winds typically blow out over the ocean as opposed to off of the ocean where they would be bringing moisture. It actually blows towards the ocean. Okay, that kind of makes sense to everybody, okay, how well that works. All right, good.